Picture this. You're standing in ancient Rome somewhere around 100 AD. The city is absolutely packed with over 1 million people. That's more humans crammed into one place than anywhere else on Earth at that time. And here's the thing that should blow your mind. Every single day these Romans are using about 300 gallons of water per person. That's actually more than what most modern Americans use today. So how on earth did they pull that off? No electric pumps. No modern machinery. No computers to calculate anything. Just human brains, human muscles, and an absolutely insane level of engineering genius. The answer? Aqueducts. And let me tell you, once you understand how the Romans actually built these things, you'll never look at a bridge or a tunnel the same way again. Let's dive in. What's up everyone, welcome back to the channel. Today we're going deep into one of the greatest engineering achievements in human history, the Roman aqueducts. And I don't just mean we're gonna look at some pretty arches and call it a day. No, we're getting into the nitty-gritty. The actual construction. The planning. The blood, sweat, and honestly probably a lot of tears that went into building these massive structures. Because here's what most people don't realize, those beautiful arched bridges you see in pictures? That's only about 5% of the entire aqueduct system. The real magic happened underground, in tunnels, and along carefully measured channels that stretched for dozens of miles. The Romans weren't just building water pipes. They were reshaping the landscape itself. So grab a drink, preferably some water since we're talking about the greatest water delivery system the ancient world ever saw, and let's get into it. Okay, so first things first. Why did the Romans even need aqueducts in the first place? Early Rome actually started out right next to the Tiber River, and for a while that was fine. People drank from the river, collected rainwater, dug wells. It worked. But here's what happens when your little village on 7 hills starts becoming the capital of a massive empire. You get more people. A lot more people. By the 4th century BC, Rome had a serious problem. The Tiber was getting polluted. Wells were running dry or becoming contaminated. And the population just kept growing. They needed a solution and they needed it fast. Enter the first Roman aqueduct, the Aqua Appia, built in 312 BC. This thing was about 10 miles long and ran almost entirely underground. It brought fresh water from springs in the hills east of Rome directly into the city. And once the Romans saw how well it worked, they were hooked. Over the next 500 years, they would build 10 more major aqueducts serving Rome alone, plus hundreds more across their entire empire. But building these things wasn't exactly simple. So let's break down exactly how they did it. Before you can build an aqueduct, you need to find water worth aqueducting. And the Romans took this step incredibly seriously. They would send out teams of surveyors and engineers to scout the surrounding countryside, sometimes traveling 50 or 60 miles from the city. They were looking for springs, natural sources of clean, fresh water that flowed year-round. Not seasonal streams that might dry up in summer. Not rivers that might be muddy or polluted. Pure, clean spring water. And here's something fascinating, they actually had methods to test water quality. The Roman architect Vitruvius wrote extensively about this. They would observe the local population near a spring. Were the people healthy? Did they have good complexions and strong bodies? If the locals were thriving, the water was probably good. They'd also look at the spring itself. Was the water clear? Did it flow consistently? They'd even boil the water in bronze vessels and check for sediment or discoloration. Once they found a suitable source, the real work began. This is where the Romans really showed off their genius. Remember, an aqueduct doesn't use any pumps. It relies entirely on gravity. Water flows downhill, and that's the only force moving it through the entire system. Which means the engineers had to create a continuous, gentle slope from the water source all the way to the city. We're talking about a grade of sometimes less than 1 foot of drop for every 1,000 feet of distance. That's incredibly precise. And they had to maintain that precision for miles. So how did they measure this without GPS or laser levels or any modern technology? They used an instrument called a groma for horizontal measurements. Basically a wooden cross with weighted strings hanging from each arm. By lining up these strings, they could establish perfectly straight lines across the landscape. For vertical measurements, they used something called a chorobates. This was a 20-foot-long wooden frame with a water-filled groove on top, essentially a giant level. By checking that the water in the groove was even on both sides, they could determine whether a surface was perfectly level or not. Teams of surveyors would work their way across the countryside, placing markers, taking measurements, recording everything on wax tablets. They'd map out the terrain, identify obstacles like valleys and hills, and plan the route the aqueduct would take. This surveying process could take months, even years for longer aqueducts. But getting it wrong would be catastrophic. If your slope was too steep, water would flow too fast and erode the channel. If it was too gentle, or worse if you accidentally had a section going uphill, the water would stop flowing entirely. There was no room for error. Alright, so you've found your water source. You've surveyed the route. Now it's time to actually build this thing. And that requires manpower. A lot of it. The workforce for Roman aqueducts was massive and diverse. You had skilled engineers and architects at the top, making decisions and solving problems. Below them were experienced craftsmen, stonemasons, bricklayers, carpenters, metalworkers. And doing the heavy lifting? Often literally? Slaves and laborers, thousands of them. The Roman military was also heavily involved in aqueduct construction, especially for projects outside of Rome itself. Soldiers were already organized, disciplined, and trained to follow orders. When they weren't fighting, they built stuff. Roads, walls, bridges, aqueducts. The Roman army was basically a giant construction company that also happened to conquer the known world. 4 major projects. You could have 10,000 or more workers on site at any given time. They'd be divided into teams, each responsible for a different section of the aqueduct. Work would happen simultaneously at multiple points along the route to speed things up. The core of every aqueduct was the spicus, the actual channel that carried the water. And this is where the real engineering came in, because the spicus had to be built differently depending on the terrain. When the ground was relatively flat and at the right elevation, the channel was built at ground level. Workers would dig a trench, then construct a U-shaped channel inside it using stone blocks or concrete. The floor and walls would be lined with a special waterproof plaster called opus signinum, made from lime, sand, and crushed terracotta. This stuff was amazing. It created a smooth, waterproof surface that prevented leaks and made the water flow efficiently. The channel would then be covered with stone slabs or a vaulted roof to protect the water from contamination and evaporation. And honestly, to keep people from messing with it. The Romans took water security very seriously. But what happened when the terrain wasn't cooperating? What if there was a hill in the way? Simple. They'd tunnel right through it. Roman tunnel construction was incredibly advanced for its time. Workers would dig from both ends of a planned tunnel, working toward the middle. They used the surveyed markers on the surface to stay on track underground. Vertical shafts were dug at regular intervals. These served multiple purposes. They let engineers check the alignment of the tunnel, provided ventilation for the workers, and allowed excavated rock and dirt to be removed more easily. Working in these tunnels was brutal. Dark, cramped, dangerous. Workers used oil lamps for light and hand tools to chip away at the rock. Cave-ins were a real risk. The air quality was terrible. This was genuinely hazardous work, and many laborers probably didn't survive the construction process. Now we get to the part everyone recognizes, the famous arched bridges that carried aqueducts across valleys. These structures are the iconic images of Roman engineering, and for good reason. They're absolutely stunning. But here's the thing, the Romans didn't build bridges because they thought they looked cool. They built them because valleys presented a unique engineering challenge. Remember, the water has to keep flowing downhill at a consistent slope. If you've got a deep valley in your path, you have 3 options. Option 1, go around it. Sometimes possible, but it could add miles to your route. Option 2, drop down into the valley and back up the other side. Not really possible with gravity-fed water unless you want to get really complicated with inverted siphons, which the Romans actually did use sometimes, but they were problematic. Option 3, build a bridge that maintains your elevation and lets the water continue flowing at the right grade. For most valleys, option 3 was the answer. Roman bridge construction started with the foundations. Workers would dig down to bedrock if possible, ensuring a stable base for the massive structure above. If bedrock was too deep, they'd create artificial foundations using driven wooden piles or layers of concrete. Then came the piers, the vertical columns that would support the arches. These were built using a combination of cut stone blocks and Roman concrete. The concrete the Romans used was actually remarkable stuff. Made from volcanic ash, lime, and aggregate, it would set even underwater and became stronger over time. Some Roman concrete structures are more durable than modern Portland cement concrete. Once the piers reached the right height, it was time for the arches. This is where things got really clever. Workers would construct temporary wooden frameworks called centering. These semicircular forms supported the arch stones during construction. Starting from both ends of the arch and working toward the middle, workers would carefully place wedge-shaped stones called voussoirs. Each stone was precisely cut to fit against its neighbors. The final stone placed at the very top of the arch was the keystone. Once this was in position, the arch became self-supporting. The weight of the stones actually pressed them together, creating an incredibly strong structure. The centering could then be removed and reused for the next arch. 4 tall aqueducts crossing deep valleys, the Romans would stack multiple levels of arches on top of each other. The Pont du Gard in southern France is probably the most famous example. 3 tiers of arches rising 160 feet above the Gardon River. It's absolutely breathtaking, and it was built around 19 BC. 2,000 years later, it's still standing. Okay, I mentioned this briefly before, but let's talk about the inverted siphon because it shows just how creative Roman engineers could get. Sometimes, building a bridge across a valley just wasn't practical. Maybe the valley was too wide, or the terrain made bridge construction impossible. In these cases, the Romans would use an inverted siphon. Here's how it worked. The aqueduct channel would feed into a large tank at the edge of the valley. From there, a closed pipe made of stone blocks with precisely bored channels, or sometimes lead pipes, would carry the water down into the valley and back up the other side. Because the water entered the system at a higher elevation than where it exited, gravity would push it through the low point and back up. Think of it like a U-shaped tube. If you pour water in one side, it rises up the other side to the same level. The Romans used this principle to cross obstacles that would otherwise be impossible to bridge. The challenge with siphons was the tremendous water pressure at the lowest point. The deeper the valley, the more pressure the pipes had to withstand. Sometimes this pressure was so great that it would burst the pipes or force water out through the joints. Roman engineers got around this by using multiple smaller pipes running in parallel, or by building extra thick stone pipe sections reinforced with iron bands. Pretty clever for people who lived 2,000 years ago, right? Once the main structure of the aqueduct was complete, there was still work to be done. The entire system had to be tested and the final components installed. At the source, the Romans built elaborate intake structures. These might include settling basins where sediment could drop out of the water before it entered the channel. There were often screens or grates to keep debris and animals out of the system. Along the route, they installed inspection points and maintenance access. Remember those vertical shafts dug during tunnel construction? Many of these were kept open, fitted with covers, and used for ongoing maintenance. Workers could descend into the system to clean out deposits or make repairs. At the destination, usually a major city, the aqueduct fed into a large distribution tank called a castellum. This is where the incoming water was divided and sent to different parts of the city. Public fountains, bathhouses, wealthy private homes, all got their water from these central distribution points. The system included settling tanks, overflow channels, and sluice gates to control the flow. It was surprisingly sophisticated, allowing operators to shut off water to different areas for maintenance or to deal with shortages. We've been talking a lot about engineering and construction techniques, but let's take a moment to acknowledge the human side of this story. Because building an aqueduct was not a gentle, pleasant experience. Thousands of workers labored in brutal conditions, quarrying stone under the Mediterranean sun, hauling massive blocks up scaffolding, chipping through solid rock in claustrophobic tunnels, working in river channels with the constant risk of drowning. It was dangerous, exhausting work. Many of these workers were slaves, people with no choice in the matter, forced to labor for the glory of Rome. Others were soldiers, following orders because that's what Roman soldiers did. Some were free laborers, drawn by wages or motivated by civic duty. We don't know exactly how many people died building the Roman aqueducts, but it was certainly a significant number. Construction accidents, cave-ins, falls, disease, these projects took a real human toll. When we marvel at the engineering achievement, it's worth remembering the people who actually did the work, whose names were never recorded and whose sacrifices are largely forgotten. By the height of the Roman Empire, the city of Rome was served by 11 major aqueducts delivering around 300 million gallons of water every day. The total length of these systems was over 300 miles. And that's just Rome. Aqueducts were built throughout the empire, from Spain to Syria, from Britain to North Africa. Many of these structures survived for centuries after the fall of Rome. Some are still standing today, nearly 2,000 years later. A few are even still partially functional. The engineering principles developed by Roman aqueduct builders influenced water systems for the next 2 millennia. When European cities began modernizing their water infrastructure in the 1800s, they looked to Roman engineering as their model. The basic physics, using gravity to move water through a calculated slope, remains the foundation of how we move water today. So the next time you turn on a faucet and clean water comes out, maybe take a second to think about the Romans. They figured out the basic principles of large-scale water distribution over 2,000 years ago, using nothing but observation, mathematics, and an absolutely relentless commitment to engineering excellence. They surveyed routes with weighted strings and water-filled levels. They carved tunnels through mountains with hand tools and oil lamps. They built soaring bridges from precisely cut stone and volcanic concrete. They moved hundreds of millions of gallons of water every day without a single electric pump. And somehow, against all odds, much of what they built is still standing. Still reminding us that with enough ingenuity and determination, humans can accomplish absolutely extraordinary things. Alright everyone, that's the story of how the Roman aqueducts were built. I hope you found this as fascinating as I did while researching it. These structures really represent the peak of ancient engineering, and I think they deserve way more appreciation than they usually get. If you learned something new today, consider dropping a like on this video. It really helps the channel grow. And if you want to see more content about ancient engineering and historical facts, make sure you're subscribed so you don't miss the next one. Let me know in the comments, what other ancient structures do you want me to cover? The pyramids? The Colosseum? Hadrian's Wall? I'd love to hear your suggestions. Until next time, thanks for watching and I'll see you in the next video.